From its initial specification to online usage, a 1687 design will need to be accessed through a series of different interfaces. This usually requires a lot of custom work to adapt the predefined vectors to the different setups. To overcome this problem, we applied our math tool to a specific abstractions to be able to obtain a full portability. The idea is first, each PDL1 algorithm is compiled to obtain a text executable. This means the vector generation is delayed until the last moment to avoid useless operations. Then we defined an abstraction of the actual interface thanks to a specific relocable vector format, which allows us to adapt the vector generation to the actual interface. This is a solution that is the current proposal for IEEE PC67.1 working group. Thanks to the abstraction, we were able to demonstrate that a given PDL1 algorithm can be executed on a series of different setups depending on the life cycle of the system. So from a high-level emulation, when we just have the specification of the instrument, we can take the same algorithm and then apply and debug it through a standalone IP co-simulation with an RTL design. Then we can make it through an DFT architecture exploration, always through this co-simulation interface. Then changing just the abstraction, but still keeping the text executable, we can bring the same algorithm to the real silicon in an ATI bring-up phase, where we demonstrated the usage of MAST on an Advantest 93K tester. Then, by changing the compilation toolchain, we can go to the last step and support a full embedded text access by executing our algorithm directly on an embedded processor on the system. This way, we demonstrated the ability with the MAST tool to completely port a given PDL algorithm through all the life cycle of the system.